Yeah, on reacting masses, the first example that you may put forward says that what mass of carbon dioxide would be produced if 6 grams was completely combusted. Okay, so meaning that 6 grams of carbon was completely combusted, then what mass of carbon dioxide would we produce? There we'll just know that from the periodic table the mass of carbon is 12. Then of course oxygen has got 16, but it's a diatomic molecule, meaning in oxygen we have 16 multiplied by 2, then producing 12 grams of carbon plus 16 multiplied by 2. Then of course here we get 32, and here we have got 12 here plus 32, then it gives us 44. Here we still got 12. So 12 grams of carbon dioxide, or 12 grams of carbon rather, reacts with 32 grams of oxygen to give 44 grams of carbon dioxide. Then 6 grams of carbon, we're going to produce what here? So we see that 12 grams produces 44, then 6 is the half of 44, meaning that 6 grams was going to produce half of carbon dioxide, meaning it was going to produce 22 grams here. That's it. Then of course the next one we would get, it says that what mass of hydrogen would be produced if 46 grams of sodium was reacted with water. So in all these reactions it's very important to write a balanced equation first. Then of course you are going to compare using the molecular masses of what we take from the periodic table. So I've got sodium here. They're asking what mass of hydrogen would be produced if 46 grams of sodium was reacted. Okay, so here sodium has got 23 grams. That's the atomic mass of sodium. So 2 multiplied by 23. Then of course water has got hydrogen, which has 2, plus oxygen, which has 16. That makes it 18. So 18 multiplied by 2, that gives us 36 grams of water here. Then I've got sodium hydroxide. I've got oxygen there with 16 from the periodic table. Then this one with 7, with oxygen with 16, then this one with 1. That makes it 17. 17 plus 23, that gives me 40. 40 multiplied by 2, I've got 80 here. So this molecule. Then of course for hydrogen, I just have 2 grams here. 2 grams. So I've got 46 grams of sodium reacting with 36 grams of water to give 80 grams of sodium hydroxide plus 2 grams of water. Then of course the question was asking what mass of hydrogen gas would be produced if 46 grams of sodium was reacted with water, meaning that here I'm reacting 46 grams. Then if I react 46 grams, of course I'm going to get 2 grams of hydrogen. Then I've got the last one here, which says that what mass of sulfur dioxide would be produced if 64 tons of sulfur was completely reacted with oxygen. Okay. So we got sulfur reacting with oxygen here. Then of course making up what? Sulfur dioxide. And the reaction is balanced because I've got one atom of sulfur here, one atom of sulfur here, then 2 atoms of oxygen, 2 atoms of oxygen this other side. Then of course the atomic mass of sulfur is 32 grams. So 32 grams of sulfur reacts with oxygen, that's 16. Okay, reacts with 16 multiplied by 2 grams of oxygen to give 32 grams of sulfur. That's 32 and 32 plus 32 grams of oxygen, so that gives me 64. So 32 grams of sulfur reacting with 32 grams of oxygen, it gives me 64 grams of sulfur dioxide. Then of course the question is asking if 64 tons of sulfur was completely reacted with oxygen. So 64 tons here, 64 tons of sulfur was completely reacted with oxygen. So if 32 reacts to give 64 grams, it simply means that half of sulfur reacts to give a double of sulfur dioxide, because 32 times 2 is equal to 64. So if 64 tons of sulfur reacts, I'm simply going to get 64 multiplied by 2, because it's supposed to give me double the tons of sulfur, and that gives me 8. That's 128 tons of sulfur dioxide. So I've got 128 tons of sulfur dioxide here. There are 3 conditions where they can ask us to calculate the number of moles. Yeah, we've got in elements and compounds. And if we want to calculate the number of moles in elements and compounds, we simply use the formula number of moles is equals to mass over molecular mass. This mass is the mass which is given in the question, or the mass that they're asking for. Then the molecular mass is the mass of the molecule according to the periodic table. Okay, so this is it in elements and compounds. That's for number 1. Then for number 2, we have got calculating the number of moles in solutions. Now the number of moles in solutions, we just say the number of moles is equals to the concentration, that is C, multiplied by the volume that's given, or the concentration that's given multiplied by the volume. Then of course we've got number 3, the last one in gases. It's number 3. If we want to calculate the number of moles in gases, we just say that the volume of the gas, the number of moles, is equals to the volume of the gas in dm cubed, or decimeter cubed, at room temperature and pressure, over 24 decimeter cubed. That's what we do. 3 conditions. In elements and compounds, number of moles is equals to mass over molecular mass. Then in solutions, we say number of moles is equals to the concentration times the given volume. Then of course in gases, we say number of moles is equals to the volume of the gas divided by 24 decimeter cubed. Okay, so we'll start with elements and compounds, calculating the number of moles in elements and in compounds. They say calculate the number of moles in 2 grams of neon. So we are going to use number of moles, N is equals to the mass over the molecular mass. Of course, here we don't have a molecule, but we actually have the atomic mass. That's the atom of what? Of neon. So the mass that we've got is 2 grams over the atomic mass of neon, that's 20, and this gives us 0.1 moles, the mass over the molecular mass. Then the next one, it says calculate the mass of 0.1 mole of oxygen molecules. Of course, we are going to use subject of formula where we had N being equals to the mass over molecular mass. This time we are going to say that mass is equals to number of moles times the molecular mass. And of course, a molecule of oxygen is O2, and it is equals to the molecular mass is equals to 16 times 2, because we have got 2 atoms of oxygen. So the mass is equals to number of moles times the molecular mass. And the question is given us 0.1 moles multiplied by the molecular mass, that's 32. So that's 0.1 multiplied by 32, and it gives us 3.2 grams. Then we move on to the next, where we are given compounds. Here we are dealing with where we are given single atoms and of course the molecule of oxygen. But then we move on to number 3, which says that the number of moles is 9.8 grams of sulfuric acid. So what's important here is to look for the molecular mass of sulfuric acid first. Mr is equals to that's H2 1 times 2 plus the one for sulfur, that's 32, and of course we've got 4 oxygen molecules, that's equals to 16 multiplied by 4. Then of course this, if we punch it on the calculator, it will give us 98. So calculating the number of moles, we just say that N is equals to mass over molecular mass. Then the mass that we've got, the mass that's been given in the question is 9.8. So it's 9.8 over the molecular mass, which is 98. Then this gives us 0.1 moles. Then of course the last question, or the last compound that we are given there, calculate the mass of 2 moles of zinc oxide, where zinc has got 65 grams. From the periodic table, we've got firstly is to calculate the molecular mass. The molecular mass is equals to 65 plus 16. Then 65 plus 16, it gives us, punching that on the calculator, it gives us 81 grams. So they're asking for the mass, so we say that the mass is equals to number of moles multiplied by the molecular mass. Then the number of moles here, we've got 2 moles multiplied by 81, then that gives us 162 grams. That's it for number 4. Calculate the number of moles at RTP in or rather at room temperature and pressure in 2 dm cubed of carbon dioxide. Yeah, so the number of moles of a gas is equals to number of moles of a gas is equals to the volume of the gas at RTP, room temperature and pressure, over 24 decimeter cubed, 24 dm cubed. And of course in this question we've got the volume of gas as 2 decimeter cubed, dm cubed over 24 dm cubed. Then this gives us 0.083 moles. Then the next question, it says calculate the volume of 0.3 mole of hydrogen chloride. So the volume of that, we are given the number of moles and we are looking for the volume. We've been saying number of moles is equal to volume over 24 dm cubed. Now the volume of a gas, is equals to, just making the volume of a gas subject to formula, is equals to number of moles multiplied by 24 dm cubed. Number of moles multiplied by 24 dm cubed. Then the number of moles is 0.3 moles multiplied by 24 dm cubed. Then of course we've got 7.2 dm cubed. And for concentration in solutions, we've got number of moles is equals to concentration multiplied by the volume, and our concentration is in moles per dm cubed. Then the volume is in decimeter cubed. Then the question says calculate the concentration of a solution containing 0.2 mole of sodium hydroxide dissolved in water and made up to 100 cubic centimeters. So here we can identify the number of moles and we can identify the volume, but now the volume is in cubic centimeters. So 1100 cubic centimeters in decimeter cubed is equals to 100 over 1000. Then of course this gives us 0.1 dm cubed. Then calculating the concentration, we say concentration is equals to number of moles over the volume. Then the number of moles given is 0.2 and the volume given is 0.1 dm cubed. This moles, then this dm cubed. Then of course taking a calculator to divide that, it gives me 2 moles per dm cubed. That's the concentration. Then of course we want to look at another similar example, just a little bit different, because this time we are given the mass of sulfuric acid, and which is dissolved in water and made up to 500 cubic centimeters. So now we are given the mass of sulfuric acid. So it's very important for us to know that the formula of sulfuric acid is what, so that we may use this mass to look for the number of moles. So we've got sulfuric acid 9.8 g of H2SO4. Then of course the molecular mass for sulfuric acid, we say 1 multiplied by 2 for hydrogen, plus 32 grams for sulfur, plus 16 multiplied by 4 for oxygen. Then calculating this, it gives us 2 plus 32 plus 64, and of course this gives us 98. So using 98. Using the formula for number of moles, we say number of moles is equals to mass over molecular mass. Then the mass that's given in the question is 9.8. Then the molecular mass is 98 grams. Then of course, punching that on the calculator, it gives us 0.1 moles. 0.1 moles. Now we have the number of moles and the volume, but our volume too is in cubic centimeters, so we need to put it in decimeter cubed. So 500 grams, 500 cubic centimeters in dm cubed, that's decimeter cubed, is equals to 500 over 1000, which is equals to 0.5 dm cubed. So this being our volume and this being the number of moles, we can now use the formula for concentration being equals to number of moles over the volume. So the concentration is equals to number of moles over volume. Then this is equals to the number of moles is 0.1 over 0.5. Then of course the concentration will come out as 0.2 moles per dm cubed. That's the concentration. Calculate the mass of copper sulfate, which needs to be used to prepare 500 cubic centimeters of 0.1 mole per dm cubed solution. So the first thing that we need to do is to identify that we got the volume here and we have got the concentration here. So we are going to use the number of moles is equals to concentration multiplied by the volume. But then our volume is in cubic centimeters, so we want to put it in decimeter cubed. So we are going to say 500 over 1000, 500 over 1000, or rather it's 500 cubic centimeters is equals to 500 over 1000, and this is now in dm cubed. Then of course this gives me 0.5 dm cubed. Then of course using my formula, I say number of moles is equals to the concentration, that's 0.1 mole per dm cubed, multiplied by the volume, that's 0.5 dm cubed. Then it gives me the number of moles as 0.05 moles, 0.05 moles. Now I have the number of moles, and of course I've got the molecular formula there. So meaning I can use the molecular formula to look for the molecular mass, so that I can now say the number of moles is equals to mass over molecular mass. But then I'm looking for the mass, so the number of moles or rather the mass is equals to number of moles multiplied by the molecular mass. Now the molecular mass of copper sulfate, I've got copper, then I've got sulfur, then I've got oxygen there. Then copper is good. The atomic mass of copper is 63.5 plus the atomic mass of sulfur is 32. Then the atomic mass of oxygen is 16 multiplied by 4, which is equals to 64 here. This plus 32 plus 63.5, and of course this gives me 159.5 grams. 159.5 grams. So the mass of the copper sulfate is equals to the number of moles multiplied by the molecular mass, of which the number of moles is equals to 0.05 0.05 multiplied by 159.5. Then this gives me, if I punch it on the calculator, I'm going to get 7.98 grams. That's it on the calculator. That's it for number 3, and that's it for the mass of copper sulfate. We are just using those formulas that we've been using in the previous lectures. Then of course we move on to number 4. It says calculate the mass of potassium nitrate which needs to be used to prepare 200 cubic centimeters of a 2 mole per dm cubed solution. So again, I can identify the volume, I can identify the concentration. So number of moles is equals to the concentration multiplied by the volume, and my volume is in cubic centimeters, so I say 200 cubic centimeters is equals to 200 over 1000 dm cubed, which is equals to 200 over 1000, which is equals to 0.2 dm cubed. That's my volume. This is the volume. Then the concentration, of course, is 2 mole per dm cubed multiplied by the volume 0.2 dm cubed. Then of course this gives me 0.4 moles. So 0.4 moles. Now using it to calculate the mass of potassium nitrate, I'll say the number of moles is equals to mass over molecular mass. Then I'm looking for the mass of potassium nitrate. So the mass is equals to, making M subject of formula, number of moles multiplied by the molecular mass. Then the number of moles, I've got 0.4 multiplied by what? The molecular mass now of potassium nitrate, KNO3. The molecular mass, it will be K. For K, I've got 39. That's the atomic mass. Then for N, I've got 14. That's the atomic mass. For oxygen, O, I've got 16 times 3 because I've got 3 atoms of oxygen. 16 times 3. Then here 48. Then here 14. Then 39 here. Then of course using my calculator, I'll get 101 grams. So 0.4 multiplied by 101 grams. Then punching this on the calculator, it gives me 40.4 grams as the mass of potassium nitrate.